Okay, for this video, you're going to want to have the notes from the first video handy. Notes, tree diagram, whatever you have. So we're going to look at one example where we find the different properties based off the graph, and then we'll look at two examples with equations. Please make sure you do stick through all the way through the third example. It does differ from the second example, so even though they're both equations. So first one, looking at this picture. So notice on this one, I'm only asking you to find the vertex, the axis of symmetry, the domain, and the range. So the vertex, notice, is going to be either the maximum or the minimum point. So I notice in this picture of this parabola, I have a minimum point. That's going to be my vertex. All I'm going to do is name that point. Well, I know I named by x comma y, and my x-axis is horizontal, my y-axis, excuse me, is vertical. So my x value, I notice I go back 1, 2, 3. So I'm going to go ahead and say the x value of my vertex is -3. And since I don't go up or down at all, I'm going to go ahead and say the y value of my vertex is 0. When I go ahead and list the axis of symmetry, I'm looking for the imaginary line that goes through the vertex to cut my parabola in half. So this line here. So again, notice that it is a vertical line. Since it is a vertical line, every single point on this vertical line is going to have the same x value. So what x value is that? Notice I have an x value of -3, -3, -3, -3. So the line for my axis of symmetry is x equals -3. And notice I'm not using the formula because instead of an equation, I'm given a picture. In the next two examples, we'll look at how the formula works. Domain is easy. I know this parabola is going to continue to kind of stretch up and go on forever. It's going to continue to widen out as it goes on forever and ever using all of the x values. So for that reason, I'm going to say my domain is all real numbers. So I can either spell out real, or I can use this funky kind of double barred or double stemmed R to show that I mean all real numbers. And then my range, notice that all my y values are going up from that bottommost y value. Nothing drops below that y value. So for that reason, I'm going to say all my y values are greater than or equal to this point here. The y value of that point is 0. Now let's go ahead and get into a little bit meatier and look at a little bit more difficult problems where we're looking at some equations. So I'm going to have two examples. For each of the equations, I'm going to find all of this stuff. So first thing I'm going to do is I'm going to find if my vertex is a maximum or minimum. So I notice that I'm already in standard form, which is good, because if I didn't have quadratic, linear, constant term in that order, I'd want to rearrange it first. I'm already in standard form, so now I also notice that my quadratic term, the coefficient is 5, which is greater than 0, therefore it opens up. Well, I know if it opens up, it has a bottom point, so therefore for letter A, I'm going to go ahead and say my vertex is a minimum. It does not take long to draw that picture. It probably takes about 5 seconds to draw it, because sometimes your brain wants to see that this is positive and think maximum, but it's opposite. It's positive, so it opens up. If it's opening up, I have to have a smaller or minimum point. For part B, I'm going to find the axis of symmetry. Well, I've already got my equation memorized. My equation for axis of symmetry is x equals -b over 2a. If you don't have it memorized, you can, for now, look it up on your in your notes or on your tree diagram. So -b, so b is always going to be my linear term. So I notice that my a is always going to be my quadratic term. So I can see that my a is 5, and I can see that my c is -6. If the term I'm looking for is not written, it must mean that that term is 0. So my linear term is 0, therefore my coefficient, or my b, is also 0. So I'm going to plug in and have -0, which there is no such thing, so I'm just going to write it as 0. 2 times 5, which gives me 0 over 10, which is just 0. So my axis of symmetry is x equals 0. And now letter C, I'm going to find the vertex. Remember, the axis of symmetry will always go through the vertex. So the really nice thing about finding the vertex after finding the axis of symmetry is you're halfway done. You already know the x value of your vertex. But the vertex is a point, so it has to have x comma y. So to find the y value, all I'm going to do is plug my x value back into my equation. So here's my equation here. So f of x, remember, means the same thing as y. So when I go to find my y value, or my f of 0, or my f of x value, I plug 0 in for x, and I get 5 times 0 squared minus 6. Well, that gives me 5 times 0 minus 6, doing order of operations, which is 0 minus 6, or -6. So there's my vertex. Part D is easy. My domain is going to always be all real numbers. for quadratics, so all real numbers, A, B, C, D, E. My range, so I've already looked at a picture of my parabola or a sketch of my parabola. I know it opens up. Since it's opening up and this is a minimum value, it means all my y values have to be bigger than this minimum value. So I'm going to go ahead and say for my range that all my y values are greater than or equal to the y value that occurs in my vertex, so -6. And then finally for part F, I have to find the y-intercept. Well, I know just like with linear equations, to find the y-intercept, the point where it crosses the y-axis, I plug 0 in for my x value. So I get 5 times 0 squared minus 6. That's going to be 0 minus 6. So that is again going to be -6. So notice that point reoccurred. So how did I get a y value of -6? I plugged 0 in for x and got -6. So that is my y-intercept, the point of my y-intercept. Again, notice I have x comma y. So if you feel like, okay, I've got it, please still watch the next example because it is a higher difficulty level than this one is. We won't have a linear term of 0, which will make a difference. All right, so doing the same thing. So example 2, I'm going to first say, is it a maximum or minimum? So I'm going to take the 30 seconds, not even the 10 seconds it takes me, and I'm going to draw it. I see my A is negative. Therefore, it opens down, which means I have a top point. So I'm going to go ahead and say maximum. For letter B, I'm going to find the axis of symmetry, which I've already got my equation memorized. If I don't, I look it up, negative B over 2A. So notice that if I label everything, I have an A value of -6, a B value of -12, and I'm not using it, but a C value of -1. So if I'm going to take negative B, that means take the opposite of what I have. So since I already have a -12, the opposite of that will be a +12 over 2 times -6, which is going to be 12 over -12, which is -1. So my axis of symmetry is x equals -1. Part C, find the vertex. Again, yay, I already know my axis of symmetry, so I already have half of my vertex done, but vertex is a point, therefore I have to have x comma y. How do I find the y value? Well, I plug the x value in. So what is y when x is -1? Let's find out. -6 times -1 squared minus 12 times -1 minus 1 gives me, order of operations says I square this -1 here first. -1 in parentheses squared becomes -1 times -1 or +1. So I have -6 times +1, which is just -6. -12 times -1 is going to be a +12 minus 1. So adding and subtracting is left, so I'm going to go from left to right. -6 and 12 is 6, minus 1 is 5. So now that I know the y value of my vertex, I'm going to plug it in here. There's the equation for my vertex. Part D, find the domain. Easy. Domain is just going to be all real numbers. Love parabolas for that reason. Part E, I have to find the range. So to find the range, that's going to be my possible y values. Since my parabola is coming down this time, I'm going to notice that all my y values have to be less than that maximum point. So I'm going to go ahead and say my y values have to be less than or equal to my vertex. I've already found my vertex, so I'm just going to look that up. So I look it up and I see the y value of my vertex is 5. So all my y values have to be less than or equal to 5. And then finally letter F, I'm going to find the y-intercept. To find the y-intercept, all I'm going to do is figure out when x is 0, what is y. So I'm going to plug 0 in for x, just like I did with linear equations. That is one of the nice things about math. Oftentimes after you learn something, you take that same something and you just start applying it to higher level difficulty. So I square the 0 and I get 0 squared is 0. So -6 times 0 is 0, that's gone. 12 times 0 is 0, that's gone. 0 minus 1 is -1. So how did I get that y value of -1? I plugged 0 in for x and got a y value of -1. And there is the point. That is my y-intercept. So a lot of stuff, a lot of steps. Again, you will have to have this all memorized. So you'll take this information. There's going to be a worksheet over these past 2 videos that you'll do. And then after that, there's going to be some group work that you're going to do off of these past 2 videos. And if you would prefer to do the group work before you do the worksheet, that is fine. If you're saying I'm struggling a little bit, it would be nice if I could work with someone before I try some stuff on my own. Please do that.